In this lesson, we're going to go over a mid-segment of a triangle, as well as the triangle mid-segment theorem. I'm going to do a couple of practice problems after we kind of review what the mid-segment theorem is, and then there's more problems on this sheet that you can practice before getting to the homework. Okay, so let's talk a little bit about what a mid-segment is, and then ultimately what the mid-segment theorem is. Okay, so I'm going to draw a triangle real quick. This triangle is going to be ABC. Okay, so I have put point A here, I'll put point B here, and then point C here. Okay, now we are going to say that there are two midpoints that I'm looking at. Right here, point D is a midpoint of segment AB, and then point E is the midsegment of side BC. Now, if you connect those, right, so anytime you connect two midpoints in a triangle, this segment is called the midsegment. Midsegment, man, that's a tough word for me to say, apparently. All right, now, once you know the vocab there of what a midsegment is, then we can move into what the triangle midsegment theorem actually states. So here's what it states. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half as long. Okay, so what this means is, based on this figure, if I was looking at this midsegment DE, I would say that segment DE is parallel to that third side of the triangle, side AC. Okay? I'm also going to say that DE is equal to half the distance of segment AC. Okay? So that's what the triangle midsegment theorem is stating. All right, so now that we know all that, let's do two practice questions together before I let you guys try some on your own. Okay, so both of them are going to be looking at this figure, and we have triangle ABC again, but this time we have points S and R are the midpoints of their respective sides. Okay, so telling us that SR, that distance of that segment, is 3x plus 14, and AC, that distance of that segment, is 8x minus 10. All right, so again, this midsegment theorem would state that segment SR is equal to 1/2 the length of segment AC. So by plugging in those expressions, 3x plus 14 for segment SR, and then 1/2 times the distance 8x minus 10 for the segment AC. I'm going to go ahead and distribute the 1/2 to the right side. So half of 8x is 4x. Half of 10 is going to be minus 5. Now I'm going to do some algebra to get my x by itself. So subtract 3x from both sides. That gives me 14 equals x minus 5. And finally, add 5 to both sides. And I get x equals 19. Okay, so we're able to find the value of x. So that's that first part. And now it wants us to find the lengths of SR and AC. Now you can do this two different ways. You could plug in that x into each of them. That's totally fine. Or you could just plug it into one of them and use the relationship that we started out saying that the midsegment SR is half the length of that third side AC. It's up to you. It's your call. I'm going to plug into SR first, which is 3 times 19 plus 14. So plugging that in, I get 3 times 19. Well, 3 times 20 is 60. So subtracting 3 from that gives me 57 plus 14. And 57 plus 14 is going to be 71 units. Okay? You can plug it into AC, or you could also just understand that if we need the value of AC the distance of that length to be half of that is equal to SR, I could just multiply this 71 by 2, and that would give me my length of segment AC. Let's confirm that by plugging in. So 8 times 19 minus 10. So 20 times 8 is 160, so take away 8 from 160, you get 152. Minus 10, you get 142. And again, that relationship is 71 half of 142, and it is. Okay? So that is everything they asked in question 1. Let's look at question 2. Same figure, all right, and it's telling us the slope of segment SR is 7/4. Find the equation of the line for segment AC. Well, the other piece of the triangle midsegment theorem is that the midsegment and that third side of the triangle are parallel. So if we know that the slope of our midsegment is 7/4, the slope of that side AC is also going to be 7/4. They want us to write our answer in slope-intercept form. So I just need a point, and we've got two options here. We have A, which is the ordered pair 2, 5. Or you can use point C, which is 6, -2. It shouldn't matter, depending on making sure you do your algebra correctly. I'm just going to choose point A, but again, it doesn't matter. I'm also going to choose point slope form to use that as a bridge to get to slope-intercept form, but you can also go straight to slope-intercept form and solve for your y-intercept B and then write the answer. Your call. We did this a ton in the first semester, so it's good review. So here's point slope form. So we have y minus, and I'm going to use point A, so y minus 5 equals my slope of 7/4 times x minus 2. Distribute the 7/4. You get 7/4 x minus. Now, if you wanted to multiply by 2, you could multiply the 7 by 2 and write 14/4. But what I want you guys to get to a place is, I would rather you do 7/4 times 2, and I want you to look across or diagonally, and this would reduce to 1/2. So that's going to be 7/2. Again, you can still get there by reducing 14/4. Move the minus 5 over with addition. So to get my answer, I need to do a quick little sidebar over here and write -7/2, plus 5. All right, so getting a common denominator, that's going to be 10/2 is the same as 5. So -7/2 plus 10/2 is going to be 3/2. So this is the equation of our segment AC. All right, so there's some questions here on the next page. I'll post the key. You can practice all of those as well. And don't forget to check out the homework on the triangle midsegment theorem, and come see me if you have any questions. Good luck.